All right, like I said, I wanted you to be on the lookout for this video for one of the more complicated problems. And some of you might be thinking, why is this one complicated? The perfect square is already done and factored for us. So I guess to some extent you're right in that if you take the square root of both sides, you'll get x minus 3/5 equals positive or negative square root of 4/5. Now we get some trickery, right? Because we can add 3/5 to both sides. And let's write that in a different color pen. We can add 3/5 to both sides and we will be left with x equals 3/5 plus or minus the square root of 4/5. But that's not simplified radical form. So how can we get it into simplified radical form? One of the things with these fractions that I haven't told you yet, that's why I'm making this video, is we can take the square root of 4/5 and think to ourselves, well, what if we take the square root of 4/5 and we ask ourselves, how can I get the radical from the denominator out of there? Because for all of these, you can rethink of it as the square root of 4 over the square root of 5. But we still have that problem where you have a radical as the denominator. So in simplifying radicals, the sequel, the advanced type of problems, this is what's called rationalizing the denominator. What we can do is we can multiply by the square root of 5 over the square root of 5. The reason why we're doing this is because the square root of 5 times the square root of 5, well, equals 5, right? That's what the definition of the square root is. So we're left with the square root of 20 over 5. All right, now it's getting more interesting because we can rewrite this. It's not going to be done completely. We can rewrite this as x equals 3/5 plus or minus the square root of 20 over 5. And then this part I really want you to see because it's going to help you so much when you get to the quadratic formula, is when you have the same denominator here, we can also rewrite it as x equals 3 plus or minus the square root of 20 all over 5. Right? Think about that. It's like saying 1/5 plus 2/5 equals 3/5, right? So you could write it as 1/5 plus 2/5 equals 3/5. But also, we know that 1 plus 2 over 5 equals 3/5. Still, one last step to do before having it done in simplified radical form completely is we have to ask ourselves, are there perfect square factors of 20? I'm pausing for a reason. Are there any perfect square factors of 20? Well, I want you to think of them in order. 1, 4, 9, 16. You only need to worry about 3 of them since the next one after 16 is over 20. And 4 is a perfect square factor. So we can write it x equals 3 plus or minus really the square root of 4 times the square root of 5. This step you probably would never write out like this. I'm writing it out to show you that you can simplify the square root of 4. So your final answer is x equals 3 plus or minus 2 rad 5 divided by 5. And even though, yes, this is the final answer, there may be other ones where you even have to go a step further in that, let's say, instead of 3 and 2 here, we had 10 plus or minus 20 rad 5. Well, then you could take it a step further and say 10 divided by 5 is 2. 20 divided by 5 is 4. And in my hypothetical, if your constant term or coefficient in front of the radical are both divisible by the denominator, you can simplify it further. But let's worry about the trilogy of simplifying tricky radicals for another day. For now, I wanted to give you a heads up on how to simplify radicals when you have fractions, as well as when you have a radical term in the denominator. I'm also going to post for you this really cool video from a YouTube channel that I think you'll really enjoy as well. But for now, like I said, goodbye. Come to me with any questions. When in doubt, give me a shout. See you soon.